Tesla says it is installing an Optimus line designed for 1 million robots a year. But a factory target and an autonomous robot are two different claims. Some public interactions used remote human assistance. Other Tesla videos describe navigation and sorting as autonomous, without publishing an attempt count. So what has Tesla actually shown Optimus doing autonomously? And does that evidence support the race toward 1 million robots a year? This is not a prediction about what Optimus may become. And it is not a claim that every demonstration was remotely controlled. This is an audit of the public record through July 22, 2026. We will separate visible physical capability, Tesla's claims, and the evidence that is still missing. For every material claim, the sequence is the same. Identify the source, state the narrow observation, name the limitation, then assign a category-level status. An official demo can be primary evidence that Tesla published a claim. It is not independent verification of that claim. Start with what Tesla has published. In October 2024, Tesla uploaded a video titled Optimus Navigating Around. Its description says the robot can explore unseen spaces autonomously, avoid people and obstacles using neural networks, and share an understanding of the environment across multiple robots. A separate sorting update says Optimus can sort objects autonomously using an end-to-end network. Video in, controls out. And Tesla's Gen 2 presentation lists redesigned actuators and sensors, faster walking, lower weight, a more articulated neck, and more capable hands. These are meaningful claims. They are also different kinds of claims. A hardware feature can be inspected as a design statement. A robot moving in a selected clip establishes that a physical action occurred in the published material. But the word autonomous adds another requirement. The task must be completed without an undisclosed operator performing the critical control. Public event reporting and Tesla's own releases establish the narrow baseline. Optimus is not merely a fictional render. Physical prototypes can walk and perform displayed motions. That category is verified. What is not automatically verified is the control method, the number of failed attempts, or whether the same result survives a changed environment. The We Robot event shows why the control layer cannot be guessed from appearance. The Verge reported that attendee Robert Scoble learned humans were remotely assisting the Optimus robots. He later clarified that an engineer said artificial intelligence handled the walking. TechCrunch reported the same boundary. Sources said the prototypes could walk without external control, while remote employees oversaw many attendee interactions. At least one robot serving drinks acknowledged that it was being assisted by a human. That does not make the event worthless. It makes the evidence narrower. For many conversations and synchronized gestures at that event, human assistance is verified. For walking, AI control was reported, but the public record reviewed here does not provide an uncut route, intervention log, or failure count. The two wrong conclusions are mirror images. The robot moved, so every interaction was autonomous is unsupported. A human assisted the conversation, so every step was remotely controlled is also unsupported. A humanoid can switch control modes. The audit has to follow the mode, not the costume. To move navigation from claimed to verified, the missing test is straightforward. First, define a baseline. The same robot traverses a known route with a fixed distance and fixed obstacles. Then change one variable. Alter the obstacle layout, or use a genuinely unseen route, while keeping the task boundary and completion rule identical. Now count every attempt. Count completions, contacts, stops, remote interventions, resets, and total time. Report the denominator, not only the best run. Sorting needs the same discipline. Use the same tray, the same task definition, and a disclosed set of objects. Then change object position or introduce controlled variants. Count grasp errors, misplaced items, recoveries, cycle time, and operator input. The changed variable matters because a robot can succeed for very different reasons. A memorized route, a carefully prepared object layout, or a remote correction can produce the same final image as a genuinely generalized policy. The test has to keep everything else fixed long enough to isolate which explanation survives. And interventions need a definition. Is a human allowed to select the task, reset the scene, approve the next action, or take over a joint? Those may be reasonable development tools, but they change what the word autonomous means in that trial. Tesla's video descriptions make the strong claim: autonomous navigation, autonomous sorting. But the reviewed public sources do not disclose the attempt count, intervention count, or comparable baseline. That does not prove the private system performs badly. It means the public evidence cannot establish the success rate. A successful clip and a success rate answer different questions. The first says the task happened. The second tells us whether the task is useful. Now the scale claim. Tesla's own regulatory language is more bounded than a million-unit headline. Its 2025 Form 10-K calls Optimus a general-purpose autonomous humanoid robot in development. The same filing says Tesla had yet to commercialize bots, describes the industry as commercially nascent, and warns that demand and business success are uncertain. In January 2026, Tesla called Gen 3 its first Optimus design intended for mass production. It said production line and supply chain preparation were underway, planned to begin production before the end of the year, and warned that installed capacity is not the current production rate. By April, the physical commitment was clearer. Tesla's SEC-filed update labeled both California and Texas Optimus capacity as construction. It said first-generation lines were being installed in anticipation of volume production. The Fremont line was described as designed for 1 million robots a year. A second-generation Texas line was described as a long-term 10 million per year design. Independent reporting adds timing and physical context. In April, TechCrunch reported production had not yet scaled, and that ground had been cleared outside Tesla's Austin factory. Electrek reported a late July or August Fremont start, no 2026 volume target, and a rate Musk called impossible to predict. In July, TechCrunch reported that Model S and Model X lines had been removed at Fremont to make room for Optimus. The filed Austin image matters because it is not a concept rendering. It shows site preparation labeled by Tesla for an Optimus factory, with Gigafactory Texas in the background. The Fremont change matters because removing an existing vehicle line is a real opportunity cost. Together, those records support a bounded conclusion. Tesla is committing land, tooling plans, and factory space to Optimus. They still do not tell us whether the manufacturing process is stable. A line can be under construction while robot design, suppliers, tooling, software, and yield remain in development. Tesla itself lists manufacturing ramp uncertainty in the filing. So factory preparation is not just a render. Construction and line transition are underway. But design capacity is not installed capacity. Installed capacity is not production rate. And production rate is not useful deployment. The reviewed record still does not provide current robots per week, production yield, usable inventory, or customer deliveries. Even a completed factory would answer only one part of the question. Productive deployment requires a named task, a site, hours worked, useful output, intervention burden, downtime, and maintenance. The reviewed sources do not establish those numbers for recurring Optimus work. Safety has its own denominator. A humanoid sharing space with people needs disclosed stop behavior, force limits, fault handling, and a defined operating boundary. Industry experts have identified that shared space risk, but the source reviewed here does not provide an Optimus-specific safety test or incident rate. And the economics cannot stop at the robot's price. The comparison has to include remote supervision, integration, charging, maintenance, downtime, and any human labor transferred from the task to the control room. Without those fields, working at Tesla can describe a prototype trial, an assisted demonstration, or a productive shift. Those are not equivalent deployments. This is why deployment should be treated as a ladder, not a switch. A prototype can be physically present in a factory. It can perform a recurring task with supervision, and it can eventually deliver useful output with an acceptable intervention rate. Each rung is progress. Each also requires different evidence. The public record reviewed here establishes development activity and factory preparation. It does not establish the final rung. Here is the verdict by category. Working physical prototypes, verified. Optimus exists as functioning hardware and performs displayed physical motions. Human-assisted social interaction at robot, verified for that event. This does not determine every walking motion or every other demo. Autonomous navigation, claimed. Tesla makes a specific claim, But the reviewed public record lacks an uncut repeated trial and intervention denominator. Autonomous sorting, claimed for the same reason. The statement is specific, the public success rate is not. Repeatability, unknown. No attempt and failure denominator was established. Safety boundary, unknown. Controlled public material does not define fault behavior or safe operating limits. Factory preparation and line installation, verified as underway. Tesla's filed materials identify construction, and independent reporting corroborates physical site and line transition. 1 million robots per year, a claimed design target, not current output. Current Optimus production rate, unknown. External customer deployment, unknown. Productive internal deployment and task economics, unknown from the reviewed record. That scorecard is not a verdict that Optimus cannot work. It is a verdict about what the public evidence currently supports. Unknown is not a negative score disguised as a neutral word. It means the answer may exist inside Tesla, but it is not established in the reviewed public record. Claimed is also not a dismissal. It means the company has stated something specific enough to test, and the next evidence requirement can be named. And the mismatch is now clear. The factory ambition is becoming physical faster than the performance evidence is becoming measurable. The verdict changes with evidence Tesla could publish. Show uncut repeated navigation and sorting trials. Define the task. Report attempts, failures, interventions, cycle time, and runtime. Disclose the operator boundary. Publish the safety stop conditions. Report current output and yield. Then name one recurring internal task with hours, useful output, downtime, and supervision. That would connect a selected demonstration to repeatable work, and repeatable work to the factory being built around it. The factory is becoming visible. The next milestone is not another capacity target. It is a denominator. Thank you for watching. Please subscribe to the Machine Audit and stay tuned for new videos.